Welcome to the 76th lecture of digital electronics. In lecture number 75, we have dealt with an introduction to parity generators and checkers. In this lecture, we are going to deal with 4-bit parity generators and checkers. Moving further, coming into 4-bit parity generators and checkers. Okay. So here I am having a 4-bit input data. Input data or the sending data. The sending data is 4-bit. The receiving now from this data, parity bit is generated. Parity bit is generated. Okay. And at the receiving end, parity is checked. Parity bit is checked. So here the main aim is to cross check the parity bit generated and parity bit checked or parity bit checker. Okay. So let me directly go into the 4-bit generator. 4-bit parity generator. Yeah. So here I will explain both even parity generator as well as odd parity generator. Now here I am having a 4-bit input data. So the data I am having is D0, D1, D2 and D3. Data which I am having is D0, D1 and D2, D3. Now what is even parity bit, and if it is odd parity, it becomes odd parity bit. So 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. Sorry, this an error is there. One second. For D0 I am having 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. And 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. 0, 0, 1, 1. 0, 1, 1. 0, 1, 0, 1, 0, 1, 0, 1. 1, 0, 1. 1, 0, 1. Okay. Now, so let me check for these parity bits. Yeah. And draw some lines. I will get confused. That is why. Parity bits. Okay. Now coming into parity bits. If it is an even parity, so 0, 0, 0, 0, even parity is 0, 1, 1. Here again even 1. Double 0, double 1. So 0. You need even number of ones. 1, 0. 2 ones are there. So it is 0. Here, there are 3 ones are there. So it is 1, 1, 0. 2 ones are there. So it is 0. 3 ones are there. So you get 1, 2 ones. So it is 0. 3 ones, you give a 1. 3 ones, you give a 1. 4 ones, you give 0. That is even parity. Now coming into odd parity bits. Yeah. 0, 0, 0, 0. There are no ones. So you can add odd parity. 1, 0, odd number of ones. 0, odd number of, you add a 1, 0, 1. That means total there are 3 ones. Here there is 3. So 3 means nothing is there. Nothing is required. 1, 0, 0, 1. One more required. 1, 0, 1, 0. 2. One more required. Then 1, 1, 1. Nothing is required. 1, 1, 0. 1 is required. 1, 1, 0, 1. Nothing is required. 1, 1, 1. 0. Nothing is required. 4 ones. So you need to have one more one. Okay. So that is regarding odd parity. So I have given the truth table for even parity as well as odd parity. Now, how will you find an expression for this even parity? That is a question. Okay. So even parity you can find it as, okay, you need to find the expression for even parity, the minimized expression for even parity. Okay. So it is better to go for a truth table. Okay. It is better to go for a truth table. So if I am going for the truth table, yeah, okay. If I am going for that, okay, or you can take it directly, no problem. Without going for truth table itself, we can take it directly. Yeah. So P even. If it is even parity, you can write it as D0, D0 bar, D0 bar, D1 bar, D2 bar, D3, or D0 bar, D1 bar, D0 bar, D1 bar, D2, D3 bar, D2, D3 bar, or next one comes here, that is D0 bar, D1, D0 bar, D1, D0 bar, D1, D2 bar, D3 bar, D2 bar, D3 bar, or 0. You will get D0 bar, D0 bar, D0 bar, D1, D2, D3, D1, D2, D3, or this one is D0, D1 bar, D2 bar, D3 bar, or here you will get D0, D0, D1 bar, D2, D3, or here D0, D1, D2 bar, D3, or here what will you get? Here D0, D1, D2, D0, D1, D2, D3 bar. That is expression for even parity. Okay. Now how will you check for this even parity? Now see, here 0. Now see, I have already mentioned that XOR gate is a basic key gate for checking for generating a parity bit. Now if I am checking in direct form, 0 XOR 0 is 0. So everything is 0, you will get 0. 0 XOR 0, 0. 0 XOR 0, 0. That 0 XOR 1 is 1. 0 XOR 0, 0. 0 XOR 1 is 1. 1 XOR 0 is 1. So 0 XOR 0 is 0. 0 XOR 1 is 1. 1 XOR 1 is 0. So you are getting this term. 0 XOR 1 is 1. 1 XOR 0 is 1. 1 XOR 0 is 1. So you will get 1 here. Okay. So if you are looking for even parity, you will get the expression as D0 XOR D1 XOR D2 XOR D3. That is actually the simplification of this expression. So for even parity you will get it as D0 XOR D1 XOR D2 XOR D3. Whereas if you are looking to the odd parity, what is odd parity? Odd parity is the exact complement of even parity. So you can write odd parity as D0 XOR D1 XOR D2 XOR D3 whole bar. Okay. If you look into the odd parity, you can see that it is exact complement of even parity. So 0 1 1 0 1 0 0 1 1 0 0 1 1 0. So that is odd parity. Now I am going to explain about the logic circuit for 4-bit parity generator. Logic circuit for 4-bit parity generator. Okay. So what you have? What you have is D0 for even parity. For even parity, what I have is D0 XOR with D1. That result is XOR with D2. Right? That result is XOR with D2. So I am going to explain with the 2-input XOR gates. Again, that one is XOR with D3. Okay. So here you will get the parity bit. This is the parity or even parity. Now, how will you find for how will you take the odd parity? So you are going for odd parity. The logic circuit will be like this. D0 will be there. D0, D1, D2, D3. This is parity generator. So D0 will be XORed with D1. Then that result will be XORed with D2. That result will be again XORed with D3. And again, at last you should have a note. At last you should have a note. So you will get here you will get odd parity. Okay. That means the parity bit is actually generated by the combination of the 4-bit data. Okay, the 4-bit data is D0, D1, D2, and D3. Okay, so this is basically a 4-bit parity generator. Okay, that is in the center side. Now the data is generated along with the parity bit. Now what you have to do? Next step is at the receiving end. We need to check whether that data is received. Okay. So next part is I am going to deal with the receiving part. I am going to deal with the receiving end. In the receiving end, I need to check whether the data sent by the sender is received. There we need parity checker. Okay. Okay. Now how will you check for this parity? That is a question. So while coming into the receiving side, you have, if it is odd parity, what you have is D0, D1, D2, D3 and odd parity bit. And for if it is even parity, what you have is D0, D1, D2, D3 and even parity bit. So even though the input is 4-bit, at the receiving end you have 5-bit inputs. That is D0, D1, D2, D3, D0, D1, D2, D3 along with the corresponding parity bits. Okay. Now I need to check for this odd parity. As well as even parity. How is it possible? Okay. So I am going for checking with even parity. Okay. Checking with even parity. Checking with even parity. That's it. Now I have the data as D0, 4-bit data as D0, D1, D2, D3. Okay. First of all, add the even parity, that is P even. Okay. Now parity bit is coming in. Okay. Now how will you check? That is the next question. So how will you check is, if even parity is coming in and if I am XORing with or I will do it in another track. Okay. If this parity bit becomes 1, then only you can say that it is even parity, right? Clear? That means if I am going for this even parity, if PU or even parity is equal to 1, then only you can say that the given logic circuit satisfies the even parity criteria. That means even parity is 1 means 1 only for this corresponding data. Okay. Here you no need to consider zeros. Now I am going to check the error. Okay. How to check the error? Error means I need to check the parity at the receiving end, term it as error, and check that error with the parity. Okay. So you have actually what you are doing is a parity check at the receiving end also. Okay. That is what I am doing. So here what I am going to do is again do the same thing. D0 XOR with D1. Okay, you will get one data. Again that data is again XORed with D2. Is XORed with D2. Again that data is XORed with D3. The same data is XORed with D3. Okay. And the obtained okay. So this generates the parity, right? Okay. This generates the parity bit. Now for the receiving end, one more input is there. What is it? That is even parity bit. You XOR that result here. You XOR that result here. Okay. And there you will get the error or E. Okay. Now see here what you can see. Here you are going for even parity, right? Okay. If even parity is 1, you can say that there is no error, right? Sorry, if even parity is 1, what happens? And even parity is 0, what happens? That is the question. Now I am considering the first case. Okay, I will consider 2 cases for example. So the data are 0, 0, 0, 0. That is D0, D1, D2, D3. So what is coming at this point? So what is at point A? At point A, you will get the value as D0 XOR D1 XOR D2 XOR D3. So what is the value there? 0 XOR 0, 0, 0 XOR 0, 0, 0 XOR 0, 0. So you will get A as 0. Then what is the error? Error is A XOR P U. So what is it? 0 XOR. What is the parity? Parity is 0. Parity is 0. So 0 XOR 0 is 0. Okay. So if E is 0, which means that there is yeah. Okay. Now see here you will get the value of E as 0. E is 0 here. Along with you check the parity bit of the first case. Here parity bit is also 0. So what we can say? We can say that there is no error. There is no error. Okay. Right? So here you are checking for the even parity. Now let me check for the other part. Okay, that means for this even parity, take the second data. That is I am taking this data. I am taking the second data here. That is 0, 0, 0, 1. I am taking the second data. That is 0, 0, 0, 1. What is the parity bit there from the center side? The parity bit there is 1. Parity bit there is 1. Okay. So here P even is 1. So this is D0, D1, D2, D3. So here what do we get? 0 XOR 0. So okay, at the point A, what we get is D0 XOR D1 XOR D2 XOR D3. So what is it? 0 XOR 0, 0, 0 XOR 0, 0. Then 0 XOR 1, 1, 1. Now what is error? Error is A XOR PU. So what do we get? We get 1 XOR 1. 1 XOR 1 means again 0, which means that the error is 0, which means that there is no error. Which means that there is no error. Okay. Now, here what does that mean? Here PEV is equal to 1, so okay. Which means that the exact data is received. If no error is 0, what will happen to the error? If you are getting E is equal to 1, we can say that the incoming data is errorful. If E is equal to 1, we can say that the incoming data is errorful. Okay. So I hope you have got the point. So what we are checking is you are having a 4-bit data at the input, generating the parity. Okay. Now what we are doing after generating the okay. So we have dealt with the 4-bit parity generator. Now at the receiving end, what we have D0 receiving end, the data incoming are D0, D1, D2, D3 as well as parity. Now coming into even parity. If even parity is there, what should we get? Your error should be equal to 0 if there is no error, and E should be equal to 1, which means that there is error. Okay. So what is A? A is D0 XOR D1 XOR D2 XOR D3. That is at the point A, and you are XORing it with the even parity. Okay. Now here in the first case you are getting 0. In the second case you are getting A as 1. Yeah, and even parity you will get 1. So you are 1 XORing 1 means it is 0, which means that there is no error. Which means that whatever data you are getting there, it is directly mapped to here. Okay, which means that there is no error. Okay, so we are not mapping the parity in a direct way, we are mapping the error. Okay, so what you are doing is from the sending end you are taking the parity, and in the receiving end along with the parity and data you are checking for the error. Okay, now coming into one more thing. So here one more step. So here A, at the point A what we have is D XOR D1 XOR D2 XOR D3, right? And what is error? Error is A XOR P even parity. So how will you find it? So if you are going for this D0, if you are going for a third case, 0, 0, or I will go with a complicated case, that is 1, 1, 1, 0. Okay, go with 1, 1, 1, 0. Okay. If it is 1, 1, 1, 0, what is the parity there? If it is 1, 1, 1, 0, the parity, even parity obtained there is 1. 1, 1, 1, 0 means even parity obtained there is 1. And you have to find the value of error. That is it. So this is D0, D1, D2 and D3. So what is 1 XOR 1? 1 XOR 1 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. And that 1 is XORed with 1. What is the answer? 0. That means there is no error. Okay. So that is how we are checking for error. Okay. Whereas at the instant when error becomes 1, we can say that it is not according to the even parity. That means at the receiving end there is some change of that data. Okay. Now coming into next part. Coming into explain about this odd parity checking. odd parity checking. Okay. Again I am having the data D0, D1, D2, D3 along with odd parity, that is P odd. So D0 is XORed with D1, same thing, and that is XORed with D2, and that is XORed with D3, and the final answer is XORed with parity, that is P odd. Here we are getting errors out. Okay, so basically parity generating or checking means XORing the bit by bit, XORing bit by bit. Now let me check for the first case, that means D0, D1, D2, D3. First I will find the point A. 0, 0, 0, 0. Okay, so here what will be A? A is D0 XOR D1 XOR D2 XOR D3. So here what will you get? 0 XOR 0, 0, 0 XOR 0, 0, 0 XOR 0, 0. So A is 0. Now what is E? E is P odd parity obtained XORed with A. So in the first case, what is the odd parity obtained? In the first case, the odd parity obtained is 1, right? Odd parity obtained is 1. So answer is so here error is 1 XOR 0. 1 XOR 0 is 1. Okay, 1 XOR 0 is 1. Go with the second case. So D0. D0, D1, D2, D3. D0, D1, D2, D3. I am going with 1. That is 0, 0, 0, 1. Okay. So what is A? 0 XOR 0 is 0. 0 XOR 0 is 0. 0 XOR 1 is 1. XOR. That is only 1. Yeah. That is 1. Now what is error? Error is basically A XOR what? A XOR P odd. Okay. In the second case, what is odd parity? Odd parity is 0, right? We can say that that is 1 XOR 0. That is 1. So in odd parity checking, what we can see is that when error is equal to 1 or when the E is equal to 1, which means that there is no error, whereas when E is equal to 0, the given the incoming data is errorful. Okay, whereas in the case of even parity checking, it was in the ulta way. When E is equal to 0, there is no error, whereas when E is equal to 1, it becomes errorful. Whereas in the case of odd parity checking, what happens is that when E is equal to 1, there is no error, and when E is equal to 0, it is errorful. Okay, let me go with the one another set. So I will go with the 1101. 1101. 1101. POD 0. I am going with 1101 and with odd parity as 0. Okay. So this is D0, D1, D2, D3. So what is A? A is basically D0 XOR D1 XOR D2 XOR D3. What is it? 1 XOR 1 is 0. 0 XOR 0 is 0. That 0 XOR 1 is 1. Now what is odd parity? Odd parity is 0. Therefore what is E? E is A XOR P odd. So what is it? That is 1 XOR 0. What is the answer? 1. So here we can see that E is equal to 1, which means that the incoming data contains no error. Okay. that is to finalize to wrap up for even parity. For even parity, if E is equal to 0, there is no error, and for E is equal to 1, there is error. Whereas for odd parity, if E is equal to 0, there is error, and for E is equal to 1, there is no error. Okay, so that is the wrap up. So coming into the basics, or again going back to the lecture. So here I am dealing with the 4-bit parity generators and checkers. So here the generation is from the sending end and checking is from the receiving end. So I have drawn a truth table having even parity as well as odd parity. Okay, and derived the expression for even parity as well as odd parity bits, and the logic circuit as a 4-bit parity generator for odd parity and even parity is developed, and this is for P odd is equal to 1. Now going into the next part. So in the receiving end, if it is odd parity, you have the incoming data as D0, D1, D2, D3 as well as odd parity, and in the if it is even parity, it is D0, D1, D2, D3 and even parity, right? Now coming into now how to check for even parity? That means it is similar to how to check the parity between the sending side. Okay, that means if it is even parity, E is equal to 1, if then there is an error, and if E is equal to 0, there is no error. Whereas in the case of odd parity, if E is equal to 0, there is no error, and E is equal to 1, there is error. Okay, so that is something regarding 4-bit parity generator and checker. Okay, so I think you have got an idea about parity bit generators and checkers. Okay, so with that I am ending with the topic of this parity generators and checkers, and in the next lecture we will be dealing with ALU, some basic circuit of ALU, and after that we will be dealing with this one, sequential digital circuits. Till now we are dealing with the combinational circuits. So after that we will deal with sequential digital circuits. Thank you.